Here we go. Okay, hello. Good morning, everyone. Welcome to Fit 2107 again, software quality and testing. And this is week 7 already. Today we will continue talking about white box software testing, part 2. Last week we talked about statement coverage, branch coverage, decision coverage, condition coverage, and also MCDC as well, modify condition and the decision coverage. And today we're gonna talk about more details for the other kind of coverage as well. Okay. Yeah, let's get started. Today we will mainly focus on the part coverage, and I think this is the only one. And we will need to understand what is the control flow graph as well. So probably these are the two key topics that we are going to cover today. Okay, so basically, what's the part coverage, right? What I want to say here is that last time when we talk about the branch or the condition, we just look at it individually, but it's not the combination or the part of the whole program, right? Maybe I should draw something. I think this is probably something that you remember before. Let's say this is a condition one, true and false, and probably this is another branch, another condition, and then it will be true and false like this, right? So this is like a nested if else. But let's say if you have another uh, another if condition, right? So it's going to be condition 3 like this, okay? And true and the false. When we look at it in the past, in the previous week, we look at it individually. But basically, in fact, when we consider the whole program, right? At the end of the day, the after the condition one is true, finally the program will reach this branch anyway. Okay, so that's why we need to consider each of these as a part, right? And the key goal here is that how can we ensure that we design the test cases that exercise all of the part. Okay, that's why we need to understand what is the part coverage today. Okay, let me clear my screen a little bit. Uh, Mouse. Yep. Okay, so the key goal by the basic definition here, part coverage actually is not just only consider the full combinations of the all of the decision point, okay, but it also look at the structure of the sequence of the program as well. They look at both aspects, structurally and also semantically, okay, and basically, yeah, I think let's try to move to the next slide. Okay, what does it mean by the part coverage? Okay, so the part coverage is that the goal we want to achieve 100% part coverage. We want to ensure that each feasible part must be executed at least once. This is by definition. Okay, so let's take a look at this program. Mm-hmm. We have 9 lines of code here. If condition 1 is true, then F1, else F2. If condition 2 is true, and then F3, else F4, right? How many test cases to achieve the 100% part coverage? Probably before we move to the test case, let's consider first what is the part coverage here, right? What are the feasible parts? Why don't we try to draw this one together, right? Okay, so basically, this is a simple program. I think I don't need to draw. I believe I have another slide here. Okay, yeah. So basically, normally we will start with the node. Okay, this is the node, and this is the edge. Okay, this is a graph. Okay, we're gonna draw a graph. The node here represent the line number. Okay, this is the line number 1. This is a condition 1. All right. Condition 1, if it is true, then run the F1 here, function 1, okay? Line number 2, otherwise else, okay? F2, line number 4, 2, like this, okay? 5 is the merging branch, okay? And then if the condition true, actually, I would say something is wrong. Yeah. I would say this should be 6 because this is the if condition 2. Okay, line number 6. Yeah. All right. It should be 6 because 6 is the another if condition, right? If condition 2 is true, then line number 7, otherwise else line number 9, F4 here. So basically, what are the feasible part? What we are looking at it, right? In the past, we just want to decide the test case to ensure that one cover true and false, things like that. But right now, we look at the combination of the whole program, okay? The whole file. So the feasible part here should be 1, 2, 6, 7, 1, 2, 6, 9, 1, 4, 6, 7, 1, 4, 6, 9. Okay, so these are the 4 possible parts here. And how can we decide the test case to capture all of these possible paths, right? Okay, so to do that, we need to have the condition, okay, 1 and 2 as a true, true, false, false, true, false, false, true, that kind of thing. Okay, does it make sense here? If we have, let's say, if we have only one test case, okay, if we have only one test case, true and true, okay, true and true. So it's going to be 1, 2, 6, 7 like this, right? So what is the part coverage? If we have only one test case, 1, okay, 1 out of 4, that is 25%, okay? So if we have only this one, then just only 25%. If we have false, false, then it's going to be like this, right? Then we'll get 50% part coverage, okay? So if we want to capture, if we want to achieve 100% part coverage here, we need to have 4 test cases, okay? Does that make sense, everyone? Yes, okay, thank you. Okay, now when this is a ticket price program, okay, let's try to understand this one together. Let's say this is maybe swimming pool ticket price, okay? So if you are between 18 or 55 years old, if you are younger than 18 years old, that's a children, right? So you will get a concession discount. If you are less than 55, like a regular age, okay, but you have a pension status, then you will get a concession discount as well. If not, then you won't get anything, okay, no discount. But if you are older, right, if you are over 55 years old, like 56 over, then, and if you have a pension status card, then you get the discount, or you have a senior card, then you get a discount as well, concession discount, otherwise no. And for those who have a concession discount, the ticket price will be $5, but otherwise it will be $10. Okay, does that make sense? This is a simple program, but this is a complex if-else condition, right? That's so hard. How can we draw it, and how can we ensure the part coverage? It's not easy at all, because if we don't draw the control flow graph, that one, right, it's hard to understand, and it's hard to understand, like, how can I say, like, what are the parts of the program, what are the feasible parts of this program. There are so many, right? So that's why technically people use control flow graph here. This is a technique that you can use, and actually you don't need to draw by hand. You, of course you can, but I believe there's a library here, PyCFG. Okay, this is a Python package to automatically generate a control flow graph. Yeah, based on the Python program, you can use this one to generate that figure as well. Okay, and Yeah, let's say if we use that PyCFG to generate, right? And what you can see here, this is the same as the previous example. The terminology is the notation is the same. We have the node to represent each line, and then we have the edge here to represent the direction of the program of the code, right? So basically, this is the first part, right? If we look like a manually, this 1, 2, 3, 16, okay, 17, 1, 2, 3, 16, 18, 19, 1, 2, 4, 5, 6, like this, okay? This is what we can see, okay? Yeah, that 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 looks good, okay, looks good so far. But what we, let's say if we have a question, these are the feasible parts, okay, this is what we know so far. Okay. Okay. And what is a CFG? Okay. Back to the basic definition again. Okay. Normally CFG or control flow graph, it is used to analyze or the guide or to guide the testing process, and it is a graph representations of all parts. Okay. That might be traversed through a program during its execution. And normally there are two key components here. Each of the graph consists of the node and the edge. Node is a sequence of the statement. Edge is a potential path between the two statements. That's it. That's a simple basic definition. And if we look at a classic program, normally, I mean program structure, normally we will have if then else or while loop or for loop, that kind of thing, right? This is what we are, we are very familiar with. If else, think about the branch coverage or decision coverage, that one, right? We have the decision branch here, decision point, the node here, and there are two branches here, true and false, and then it is merged to another, the next line of code, right? Yeah. And this is a for loop. Think about what, no, not for loop. This is a while loop, okay? While true, why with some condition here. If it is true, then it is looping like this. Otherwise, exit, right? Exit the loop and move to the next statement, next node, okay? But just in case, in the while loop, you can have if else that you can exit the loop as well. Then normally this is a while loop, right? And probably there are some if else here, okay? If else, if some condition, and then you can exit the loop, okay? Or this is the exit from the, what is that? From the while loop. This is the exit from the if condition, okay? Does that make sense? I'm sure in the next few weeks, we may need to draw this kind of thing as well. Yeah. And this is a few more examples, right? Let's say we have 5 lines of code here. If condition, do this, else condition, do that, and then this one. Okay. Now, if we draw, translate this program into the control flow graph, normally we will start with the first line of code, okay? If, and that's the condition, okay? Condition something, true, false, okay? True, then do this, and should be line number 2. Else, otherwise, this is false, then go to the line number 3 and do that 4, okay? Yeah, and 5, this is after the if else condition, then we will come to 5 like that. Easy, okay? This is the next example, while loop, okay? While x is less than 10, okay? Start with the node line, with the statement line number 1. Then if the y is true, okay, true, then execute the line number 2 here, and then execute the line number 3. They come together. And if this is what is that? Y true is the loop, right? We can draw like this as well, okay? Otherwise, print done, okay? 4. That's it. Easy. Okay. So that's all. Where's let me clear the screen. Yeah, the part coverage, right? So let's take a look at some example here. This is a continuing example, right? We have the program, the ticket price, and let's say if we want to cover, right? If we want to know what is the feasible part if the concession is false, okay? What is that, right? Uh, this is a concession false, okay? The ticket price should be 10. But what are the conditions? What are the feasible part? Based on this program, what we know is that if we want to reach, okay, the line 16 and 18 here and 19, okay? This is what we want. And that means the concession should be false, right? The concession should be false, and the concession will be false if it goes to this way, right? This line, okay? That means age, what is that? Age is less than 55, but no pension, then you will come, you will get, you will not get the concession, or or what? If you are older, senior, okay, senior, and either you have a pension or senior card. No, sorry. If you are a senior person, but you don't have any pension card or senior card, then you get the, then you will not get concession. Okay, this is based on what we analyze in the in this Python program, right? But we need to calculate the understand the feasible part as well, identify the feasible part. Okay, this is what we want, right? Concession as false. Okay, what are the potential part to reach the concession false? Okay, yep, this one. Okay, this is what we want, and the potential part here should be 1 2 3. Okay, 1 2 4 5 6 16. This is the second one. 1 2 4 5 7 8 16. 1 2 4 9 10 11. How many already? 1 2 3 4. Okay, 5. This is 5, and this is 6. Okay, 6. There are 6 feasible paths at beginning to before we can reach the line 16 and the 19, right? So these are the 6 feasible paths that we need. Okay, no, that we need to consider. Okay. And then if we want to focus on the concession as false, okay, what are the part that allow us to reach that condition? Okay, so in this case, we already know that what is that? The concession will be false if we reach the line number 8 and the line, what is that? 15 here. Okay, so what do we need is these 2 test cases. This is line number 8 and this is line number 15. So if the input of the program following these conditions, then we can reach the concession as false. Okay, that part. Okay, and we have one question in the Q&A. Okay, yeah, I had a question which was okay. That's not about this lecture. I will answer that later. Yep, maybe I will continue. Okay. Yeah. So we talk about the parts here, but sometimes there are some invisible part as well, right? It doesn't mean that every conditions, every input value will go to the concession as false, right? For example, what is the invisible one? Like this one. Let's say if we want to get the concession as 1 2 3 16. 1 2 3 16. Okay, yeah, like these are the 2 valid parts that allow us to reach the line 16 and the 18, because concession need to be false, right? But these are the invalid one, right? Because these when the program execute through this part, the concession will be true. So it is invalid, right? In the concession cannot be false at all. Okay. Yeah. That's why in this case, it's called dead code. Okay. What I mean is that, let me try to draw this one again. 1, 2, 3. Okay. For this case, everything must be true, true, true. Everything is true. And the concession will be true. It cannot be false. So that's the dead code. It is infeasible part. We will not consider about that. All right. It's called dead code. Mm-hmm. Yeah. So, question why we are looking at the concession being false specifically? Actually, not really. Maybe I should clarify this one again, right? Maybe I didn't explain it clearly. Let me try to clarify this one again. Okay. What I mean is that we often use uh, let's say in this case, we want to consider the part coverage and we need to identify the feasible part, okay, to arrive that condition, right? In this case, in this program, probably we have, if we consider everything, it will be 1, 2, 3, 6, 16, 18, 19, or that kind of thing, every combination, right? But not everything is feasible. So when we look at the part coverage, I would say that we should look at only the feasible part only, right? So that's why in this case, there are some if else at the end here. That's why we need to identify the feasible part first to understand what are the part coverage. What is the total feasible part, and how can we come up with the test cases to achieve 100% part coverage? Yeah. Yeah. 1, 2, 3, 16, 17 is infeasible. No, that one is feasible, right? So 1, 2, 3, 16, 17. This is feasible. What do I mean is that 1, 2, 3, 1, 1, 2, 3, okay, and then 16, 17. This is feasible because if the age is less than 18, then concession is true. And if the concession is true, then it returns 5. But what is infeasible is 1, 2, 3, 18, and 19. This is infeasible, 18 and 19. This one, right? Because when you go to this part, right, age is less than 18, the concession is already true. When we execute between the lines between 16 and 19, it cannot go to this one at all, right? It has to go to this one. So 1, 2, 3, 18, and 19 is infeasible. What I mean is that when we do the part coverage, we cannot just look at all of the combination. We may need to consider the end outcome, right? And then do the reverse engineer, okay? Reverse engineer. What are the potential paths to achieve this exit, okay? This return statement, okay? What are the potential path, feasible path to return this one, okay? That's what I mean. Yeah. That means okay, does that make sense? So in this case, what I want to say here is that we want to consider both true and the false, identify all of the possible part. We will ignore the infeasible part, okay? And then we need to come up with the test cases to achieve that part, all right? Yeah, that's it. Okay. But there are some limitation as well, right? Exception handling. So that means sometimes when we do the part coverage, it may not be able to capture the exception, the rest and exception, that kind of thing. So the solution is that we need to use the rest or throw, okay, to catch that one. and all of the cache statement. Try cache that one. Or what is that? Compound predicates Boolean expression. If let's say the program is more complex, right? It has a more condition. If A and B or C and D not B, not D dog, that kind of thing. The part coverage does not consider that kind of conditions, so for that part, we also need to use the condition coverage anyway, okay? Let me try to explain this one again, okay? Normally, we look at this one. This is a branch, okay? We have true and the false, all right? And this is another if-else condition. Probably this can be an as well. Oh dear, how? And, or, that kind of thing. And, okay? True, false. When we look at the branch coverage, we just cover this part individually, this part individually, okay? That's the branch coverage. It does not consider the whole program. If we want to consider the whole program, we need to use the the part coverage. So it will be true, false, okay? False, true, false, that one, right? But when we look at the branch coverage or the part coverage, it does not consider all of the conditions here, whether each of the condition, let's say A, B, C are tested in both true and false or not. Okay, so that's why we still need condition coverage as well. If this is a compound predicate or Boolean expression. Okay. Yeah. This is an example, right? This is a part coverage with the compound conditions, okay? So we have if character, blah, 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 whatever, but let's say it is, we represent it as A, B, and C, right? And this Boolean expression, we can simplify as A and B or C, okay? So in total, if we use the part coverage, right? We just need only 2 test cases. Is that right? To actually, because there's no false at all. Actually, let's say if I add this one, if and else, okay? Then we just need 2 test cases to achieve true and false like this. But it doesn't mean that all of the condition A, B, C are covered. So that's why if we come up, if we go back to the last week lecture, to achieve 100% condition coverage here, we need 8 test cases. Basically, we just write the truth table here, right? And then everything will be covered as true and false. And this is a basic condition coverage. If you want to go advanced, let's say apply MCDC, then we can reduce the test case as well, okay? Yeah, that's the example 3, okay? Look at the part coverage. Normally, when we talk about the part coverage, it will be more complicated if it is a loop, right? And it can be, for any while loop or for loop, we can also use part coverage as well. But it doesn't subsume the branch or the statement coverage. So, but I think what I want to say here is that loop coverage will not be covered in this unit, okay? We just briefly touch about some other advanced technique as well, but we will not cover, it will not be assessed in this unit. Okay, that's it. I think the lecture today is quite short, and then I'm gonna talk about the assessment tool a little bit as well. Okay, yeah. Summary, that's all. Yeah, maybe I will try to answer maybe before I answer the question, I will just briefly talk about the assessment tool a little bit. FYI to everyone, right now, the instruction sheet is already available in ED, and also the practice questions and the answers here, okay, is also available in ED. Please try to understand or practice, read it well. And for the assessment tool, it is weight 25% of the total mark. and it is individual. It involves a quiz and a video presentation. And what does it mean here is that for week 7, it will be on campus. Okay, it is open book. You can access like ED STEM Fit 2107 ED STEM lessons or Moodle as well. But you should not use any Google search, ChatGPT or whatever. Okay, don't bring the printout note. Okay. For the part 1, it consists of 2 main parts. Basically, we test the knowledge test, the quiz. I would say it is a basic questions. If you understand the fundamentals or read the slide, I'm sure everyone will get full mark anyway. For the applications of the black box testing, this is we want to assess whether you can apply this technique to a given specification or not. Okay, so the first one will be about the boundary value analysis and the equivalence partition testing. The second one will be about the category partition testing. Okay, so all of these you have to complete within 60 minutes. Okay, and you should not discuss with each other at all. And for the second part, it will be their video presentation. Basically, we will give a more difficult problem. It's like a take-home exam. You can work on your own without any pressure. You can have like roughly 1 week to work on the solution. What you need to submit is where is that? Yeah, what it will be provide in the Moodle as well. So what you need to submit for the part 2 is two things. Okay, the video presentation 5 minutes and the working sheet as well. Let's say a Google Docs. Okay, and what do we mean by the video presentation is that basically our expectation is very minimum. You just create a Google Docs, put the questions into the Google Docs. Okay, write the answer, provide the answers, and start the Zoom recording. Present what is the question, how do you come up with the answer, and what are the answers. What we want to know is not just only what is the answer, but we want to know how do you come up with the answer. Okay, more of the rubrics or detail, or how do we assess, or the guiding questions will be provided in the question as well. Okay, don't worry about that. And again, this part you should not discuss with your friends again. Okay, the topics, this is one of the common questions that we received so far. For the assessment tool, both part 1 and part 2 will cover only these black box testing technique. Okay, so what is that week 4 and the week 5? All right. These are some of the FAQ, right? And some instruction as well. For the part 1, okay, so, sorry, part 1, yeah, is the timed quiz. What you need to bring, okay, very important. Your laptop that is sufficiently charged. Come to your allocated studio, okay, on campus. Bring your student ID. We need to verify whether you are the right person or not for that allocated studio time. And then you can bring pen or pencil as well, just in case you want to take some note. Work on the solution. Okay, but last night I tried to practice, pretend that I'm a student. I don't need to use any paper or pen at all. Yeah, but this is just in case. Okay. And what you can access, right? You are allowed to access Fit 2107 Moodle and the lecture slide in the ED STEM. You can use calculator apps as well. You need to do some calculation, but you should not, you are not allowed to use any online-based calculators. Don't access any other website at all. Try to stay within the ED STEM or Moodle all the time. Okay. What you should not, very important. Okay. Don't access other resources, online Stack Overflow, ChatGPT, Google Search, Translate, Google Docs, Dictionary, online calculator, no. Translation, Google Translate, no, nothing. Any messaging communication tool, no. Screen recording, no. Zoom, no. Slack, no. No WhatsApp. Okay. And what we will provide, if you need a blank paper, we can provide that as well. If you receive it, you need to write your student ID at the top, okay, of the blank paper. And when you exit the room, you should return. You have to return. You must return the sheet, okay, before you exit. Yeah. What you need to do, arrive the week 7 studio on time. For the Malaysia campus, it will be your tutorial, all right? And yeah, arrive on time. And probably the first 30 minutes, we will check you in, present your student ID. We will add you to the quiz, and then you can start the quiz. During the quiz, it is 60 minutes, okay? It will start exactly half an hour after the schedule start, okay? After the allocated studio time start. What is that? Yeah, we will check you in. Once you have checked in, then you will be able to see the quiz, okay, under the assessment tab. Probably we can start together as well, and you are not allowed to exit the room, okay? That's the rule, okay? Very important. Yeah. Yeah. So if you have any questions, right? So we will not answer any content-based queries at all. Try to attempt the quiz at your best ability. And in your browser, you should not have 3 or more tabs, okay? And you are not allowed to access ED forum during the forum, okay? Forum, you are not allowed to access the forum, but you are allowed to access the ED lessons, all right? Is that clear? Here, yeah. You are not allowed to leave the room for any reasons. If you want to go to toilet, you need to finish your business first before you enter the quiz room. Otherwise, you are not allowed in the next 60 minutes. And then, your tutor will check your quiz attempt has been submitted before you can leave, all right? So before you want to leave the room, you show your laptop that you have already finished your attempt. Otherwise, we will not allow you to leave the room. And at the last 15 minutes, no one can leave the room at all, okay? Otherwise, it will be like a mess, okay? Yeah. So for the last 15 minutes of the quiz, you are not allowed to leave the room at all. If you finish, sit tight, close your laptop, and then, practice some meditation. Probably is a good idea. That's all. I think, and don't use any ChatGPT. That's for the assessment too. Now I'm gonna answer some questions in the Zoom chat. Are those practice questions the same as a quiz on Moodle? Same style, but it's not the same question. Does it make sense? Yeah. So what I mean here in the quiz, right? The part 1.1, it will be MCQ. So we have 2 sets of questions to practice from. So let me put this way. Part 1.1, it will be multiple choice. Roughly, there will be more questions, not one, okay? I can say that there will be something around 10 questions, okay? For part 1.2, this is just an example. There will be more questions as well. And this one is just a category partition testing. What you need to understand is that there will be this one as well, boundary value analysis, but it's not appear in the practice question. It is easy. So if you understand the slide, then everyone can do it, okay? Boundary value analysis. There will be, this is like a one big question. There will be sub questions. 1.2b, one big question, one scenario, and there will be multiple sub questions as well. Part 1.1, roughly 10 questions. I feel that it is doable within 60 minutes. Okay. Yep. I had a question which was related to black box testing. Suppose we have two inputs with 9 different possible choices that a user can make. Do we always include one additional test case for invalid or incorrect input when we're trying to calculate? A user, no, you don't need to. Yeah. Yeah, you don't need to. So in this case, if you have two inputs with 9 different choices, the answer should be 18 potential test frame without considering the constraint. Okay, does that make sense? Yeah. While I was doing the practice exam, there was one question which neglected this. Okay, I don't know what do you mean. Okay, that's all. Any other questions? Any other questions at all? Otherwise, we can, when video question are released, after you finish the quiz, yeah. After you finish the quiz, then you will receive the part 2 question immediately. Yeah. And for those what I understand that everyone wants to get the mark as high as you can. What I want to recommend is that try to do it by yourself. What you should not do, remember the questions, take the questions out of the room, write the note, share it with your friends. I would say that we have a large numbers of question bank. Each of the student will get different sets of questions randomly. The answer, the choice will be shuffled. Everyone will get different variations. There's a less chance there's a less chance that everyone will get the same question. Okay, so you don't need to try to remember the questions at all. Okay, it won't help. Yeah. Yeah. This was in example 1. What do you mean? Do you want to speak? Do you want to? I don't get it. Okay, I'm aware of time. Would you mind send me an email or post in ED? As hidden is fine as well. If you have more questions, I will try to answer. Yeah. What do you think? Yeah. Okay. All right. Thank you so much, everyone. I try my best to answer the questions, and good luck, everyone. If you understand the concepts of the black box testing, then I'm sure everyone can complete it and get the full mark. Good luck. Yeah. Thank you. Bye bye. See you later in the afternoon.